Our second lecture video on force is going to cover force and the law of acceleration. In the last video, we learned about Newton's first law of motion. If you remember, this law told us that an object in motion stays in motion and an object at rest stays at rest unless acted on by an unbalanced or outside force. Now we will talk about Newton's second law of motion. This states that the total force acting on an object is equal to the mass of the object times its acceleration. Newton's second law is also known as the law of acceleration. The equation that we will use to solve problems involving Newton's second law of motion is force F equals mass m times acceleration a. If the mass stays constant, the larger the force applied, the larger the acceleration will be. Similarly, assuming mass is constant, the weaker the force applied, the slower the acceleration. Another way that we can look at this equation is when pushed with the same force, the more massive object will accelerate less than a less massive object, which will accelerate more. Another way that we can look at the relation between force, mass, and acceleration is if mass is kept constant, force is directly proportional to acceleration, which means as force increases, acceleration increases. If instead force is kept constant, the mass is inversely proportional to the acceleration. This means that as the mass increases, the acceleration decreases, or as the mass decreases, the acceleration will increase. If there is no net force acting on an object, the object is in equilibrium. When an object is in equilibrium, there is no acceleration. Either the object is not moving or it is moving at a constant speed. Now that we understand how force, mass, and acceleration are related, let's take a look at the typical units we will see. In previous lectures, we have talked about the units for mass and acceleration. In the SI system, mass is measured in kilograms and acceleration is measured in meters per second squared. The SI unit of force is the Newton, which is represented by a capital N. If you are looking strictly at the units for force, mass, and acceleration, you may notice that 1 Newton is equal to 1 kilogram meter per second squared. In the English system, mass is measured in slugs and acceleration is measured in feet per second squared. The English unit of force is the pound, abbreviated lb. 1 pound is equal to 1 slug foot per second squared. The next video, we'll look at a couple of examples of how to solve force problems.